So like the title says here, in this lecture, we're going to talk about some special products of binomials, which are really going to help us at two different times. One, in this section, when we're actually multiplying the binomials, that's what product means. But it's also going to help us when we get to our next unit, which is going to be involving factoring. And that's going to make factoring certain binomials pretty easy. So it is going to be important that we can recognize these as these special cases. So take a minute, pause the video, and find the product of x plus 4 times x minus 4. And be thinking about this. Up until this point, the product of two binomials has always been a trinomial. Is that always going to be the case? So hit pause now, take a second to find the product there, and see if multiplying two binomials always results in a trinomial. As you could probably guess by how I phrased that question, it's not always going to be the case, because if we do that, if we say x plus 4 times x minus 4, whether we use the table method or the double distributive or FOIL or whatever we want to call it, when we do that, what we get is x squared minus 4x plus 4x minus 16. And that minus 4x and positive 4x offset each other, and we get x squared minus 16. So in this case, we multiplied two binomials and got another binomial, which isn't always the case, but it is in this one. Take a look here. We've got another set of binomials, y minus 2, y plus 2. Again, pause the video, find the product of those by using the method that we've used. So hopefully what you found in the first practice one, you found in this one as well, that when we multiplied y minus 2 times y plus 2, we got, using whatever method we wanted to use, y squared plus 2y minus 2y minus 4. And those y terms offset one another, and you're left with the binomial y squared minus 4. So what's happening here that's allowing this to happen, that's causing this to happen? Well, as we look at it, we're saying, okay, well, what we have here is the product of a sum or a difference. So in math terms, we're saying when finding the product of a sum or a difference in the form a plus b times a minus b, the product will always be a squared minus b squared, right? And that product is called the difference of squares. So when we are looking at x plus 5 times x minus 5, we get to kind of take a shortcut and say, well, there isn't going to be that middle x term like there often is when we're dealing with, say, x plus 5 and x minus 12. There will be an x term in the middle. There's not here. We're just left with x squared minus 25. And that's going to be called the difference of squares. So when we get to factoring, which is disassembling these things, we are going to want to be able to recognize that as the difference of squares. FOIL this one out. Take the time to do x plus 2 times x plus 2. See what happens here. Now, x plus 2 times x plus 2 could also be written as x plus 2 squared. Don't get fooled by that. Be able to make sure you recognize that this down here, x plus 2 squared, is the same as x plus 2 times x plus 2. A lot of people miss that. But if we do when we factor it out, when we multiply the two binomials, we get x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. Okay, well, is there maybe a shortcut that we can look at and say, all right, I see what's happening here. Let's look at another one. Take a second right now, pause the video, see if you can't find the product of x minus 3 times x minus 3. And if you want, try to just, if you think you know what it's going to be without actually doing any of the work, jot that down too. So when we square x minus 3 and do x minus 3 times x minus 3, we get x squared minus 3x plus 9. As a result, we get x squared, come on now, x squared minus 6x plus 9. This is what's called a sum, a square of a sum or a difference. And you might have noticed this. We've got two different examples here. If you're squaring x plus 6, like we are in that left-hand example, right? The first term is always going to be the first term squared. The third term is always going to be that 6 squared. That middle term is going to be 2 times the product of x and 6. So rather than necessarily FOIL something or use the table method, you could look at that and say, oh, okay, I'm squaring x plus 6. So I know I'm going to square x. I'm going to multiply 6 times x and then double it to get my middle term and then square that third term. And it's going to hold true every single time. The only difference, if we're finding the difference, is that if it's a minus b squared, like the examples on the right rather, if you had x plus 7 squared, you're still going to square x for your first term. You're still going to square negative 7 for your last term. The middle term is going to be the product of 2x and negative 7. So it's going to be negative 14x. Again, this is probably going to be maybe a little more helpful when we're talking about the factoring of these things and not necessarily the product of these things. But these are two of the special cases that if you can start to like recognize, oh, that's one of those special cases, you might be able to save yourself some time and effort. Right? You're going to get a chance to practice some of these on an attached worksheet. So please let me know if you have any questions, and we will definitely go over this more in class when we're back together. Hope this helped.